Hi, hello everyone.
Hi everyone.
So we are going to solve assignment 8.
We are in problem 8.4, Statistical Learning.
So anyway, let's solve. So here, how to state the likelihood of these every 50 observations.
First of all, what is the formula of the likelihood?
So
What is the
likelihood-
formula of the likelihood? The original formula, I mean.
So, so, so actually, like this. This is the likelihood of given the class Y given observation X, right? So usually we have observations, the features X, and then we can calculate the likelihood of the class Y. Usually we have been doing like that. But what is that likelihood in this situation? Likelihood of these observations. So here, rain, and these are the cases: ground wet and bucket full. Two attributes.
We can go to the slides.
So let's go to this.
ChatGPT solution.
Yeah, ChatGPT.
So how ChatGPT solved it?
So like this. So we have this five probabilities. So this is 19 days. This is 15 days. 16 days. And 11 days. And 5 days.
Can you go to the table?
Let's go to the table.
So probability that it rains, 19
So we
days.
have, so
10, 15, 15 and 6, 21, 21 and 4, 25 days.
Not true.
It's not true. So
So
raining,
so
10, 10 plus 5,
days.
it's 15, 15 plus 6, it's 21, 21 plus 4, it's 25.
25. You're right. 25.
So probability that the ground is wet given that it rains. So yes, 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 yes. 4 values, 10,
No,
5,
no.
15.
Rain is yes.
So yeah, 10 plus 5, it's 15. Yeah, 15.
This
This is correct.
this is 15, correct?
Correct, yeah.
And not rain.
Wet, not rain, so here 11.
11.
So it's not true.
This is 11. So actually this is probability. So this is half, right? So 50 days over, this is half. This is
50 days over 15 days over
15
50. So it's 3 over 10.
something like that. And this is
3 over 10.
10.
10, yeah. So 15 by 5
Yeah,
it's
yeah,
3,
right.
50 by 5 it's 10.
Mm.
So ground wet, not raining, it's 11 days. So the probability it's 11 over 15, 11 over 50. Probability that this is yes and it's raining, So yes, 10 plus 6, 16.
16.
Hmm.
And this is not
Yes,
rain.
not raining, so it's 3 plus 2, 5.
30 plus 2.
Yes, not raining, 3. Yes, not raining, 2, 5. So it's 5 over, so 1 over 10.
So just like that. So now we know these 5 parameters.
And the probabilities of it. This is the likelihood? No.
I
The
don't know.
likelihood, it's the probability, it's the multiplication of this times this times this times this times this, I think. Probability of y given x.
a kid prince.
Yeah.
He's a prince.
Well, I look
Hadi.
like shit. I look like shit. I should grow my beard back.
He's a UK prince.
No, today I will just
You will
shave
shave
this one.
Just
I
this
will,
one?
Yeah, I will
You
keep.
will
I will
keep
keep
this
this
one?
one.
I did this too before I completely shaved it, but I was without a mustache, so I also did not. Good. Because I'm stupid. I started with mustache first. I shouldn't do this. Yeah, you were asking about likelihood. What?
So we are in this question. So what is the likelihood of this list of fifth year observation in terms of
It's
the
like
5 parameters?
like the candy example.
Candy example.
So when you put the, it's like theta of cherry 1 minus theta of lime multiplied theta 1 of red chopper added what do you call it, wrapper cherry multiplied 1 minus theta 1 wrapper green, something like this. Yeah, and then you continue. So you have in terms of theta 1, theta 2, theta 3, theta 4, theta 5. And then when you want to calculate the likelihood or the log, then you apply logarithm and then you take those out and you have like
So this is
C.
candy.
Yeah, this is for the candy example. They have a different example here, so you have to calculate them. Yeah, there's,
Likelihood.
some people ask the same thing. They wanted to multiply those, but you don't do this, no.
So how the equation would be?
For whom is this computer?
Ahmed.
Okay. Yeah. Ahmed, yeah. How what? Look,
How
you can do this.
How the slide?
No, wait. Yes, exactly. You have it directly, or should I open it?
Wait, here I have.
Exactly. Go to
Thank you. 5.
scroll. Here. Wait. This is the equation that you need. Here. Wait. Exactly. Something like this.
Hmm.
And then scroll down.
Okay.
This is how we calculate the
Likelihood.
but so you do the likelihood and then you do the derivative with respect to theta 1, theta 2, theta 3, theta 4, theta 5. And then you have those values in terms of the hyperparameters that you have already. So, so then you go back, you plant in those values, and then you have your formula.
Okay. I will try. I will try. Not clear. AI2. have cherry, blue, green. State the formula for the likelihood. So we have try these. Green whopper. Minus set. So the likelihood is high ID observations. These suppose we unwrap N candies, C cherries, and L limes. So these are IID observations. The likelihood is zeta C 1 minus zeta L. Optimizing the product, optimizing the logarithm is that. No?
No, you have shaving machine?
I don't have it. At home.
So did you discover how to solve it?
So Mahadi give this slide.
OC times 1 minus O theta power L. So what is C and what's
So
L?
here we have C cherries and limes is 1 N minus C.
So it's like,
So can you just use another part?
so to start L
So
equal probability 1, which is raining, power. How many days it was raining?
So P1 is
P1 time power. Power C.
25.
No. Yeah, 25.
25. P1
Power
and
25 times
times
1 minus P1 power.
power 25.
No,
Why?
because this one is for not raining.
So
yeah,
50
20
minus,
yeah, 25,
50
yeah.
minus 25, right?
Yeah. So
And then-
times or plus
Times
times. Probability P2.
times
So P2 power 15, right? Into 1 minus P2 power. So 15 days it was, the ground was wet, it was raining. So 35 days,
not ground.
1 minus this. So ground raining, ground wet raining, ground not wet raining. So probability 1 minus P, this is probability not ground wet given raining, right?
Yeah, right.
This is power 35.
No, I don't think so because these cases has less than 55 because if we see the paper. So not ground wet, raining.
No,
not-
yes.
No, yes. So just these two cases, 10, right?
So yeah, 10. And here also let's.
So but this is right because this 25
Not raining.
not raining is
No.
25.
No.
So
11, 14.
so it's right. 25 right. 20 plus 2 plus 3 is
So
25.
times probability 3 power 11 into 1 minus probability 3 power. So
6.
not G, not R. So no. So it's 14, right? Times probability 4 power 16 into 1 minus probability 4 power. So not B,
Not B given R.
not
rain.
B given rain. So
Not
no,
B,
yes.
No.
No,
and
yes. No,
so
no,
here,
yes.
9.
No, yes. No,
5
yes.
plus
4 plus 5, 9. Times P5 power. P5, it's B, so yes, no. Yes, no. Yes, no. Yes, no, which is 3 plus 2, 5. Into 1 minus P5. So 1 minus P5, it's not B, not R, right?
Mm-hmm.
Not B, not R, so no. No, it's just 20.
Is it correct? So let me check.
Do you have the solution?
So here, this is the example. So we have no solution.
There is no
Because-
solution
yeah,
for this?
because it's the new problem. Not from last semester.
Why?
Right, I checked. So I think we are right. So here, cherry, L, and RC, GC, RL, GL, like this. So we can say this is probability of D H zeta 1, zeta 2, zeta 3, zeta 4.
You can say
zeta-
D given H P1, P2, P3, P4.
No, this is, yeah, we can say, but this, yeah, you're right. So this is
Yeah, it's
zeta.
like-
Zeta
yeah,
is
it's-
hyperparameter, so they just, parameter is usually
That's right. Yeah.
notated by zeta, so P1, P2, P3, P4, P5, like this. So H is hypothesis, the model we assumed. So I
So
think
what
it's
is the
right.
last question?
So let's check the ChatGPT's answer. So we figured out. So from this slide. So here we have Bayesian network, and the likelihood is like this. So this is our hypothesis, our model. So here we have just one parameter h, but we have 5 parameters. So this is the formula.
We are 100% right.
Yes. Good job.
This is 100% true.
Okay. Okay. So just following this formula, and in this case rain, not rain. So rain power 25. So P1 power 25, 1 minus P1 power 25.
So we do this for each parameter
Yeah,
of the
each
hype?
for every parameter like this. So here we have 3 parameter, and just did it like this. So we will count zeta 1, how many zeta 1 we have at the table, and 1 minus zeta 1. So like this.
سو هذه بس probability الخمسة بارامترز اللي طلعوا. P1 باور كم يوم عندك كان اللي هن 25 انتو عكسها اللي هي 1 minus P باور كم يوم. سو 25 25. P2 هي wet training اللي كانوا 15 يوم بتعدوا من الجدول. انتو 1 minus P اللي هي عكسها كم يوم. يعني هون عندك اياها انت هيدي يس صارت شو هون نو يس بتروح على الجدول نو يس بتعدهم كم مرة بيطلعوا عندك 10. وهون نفس الشيء هون صارت شو يس نو ال1 minus P3 صارت نو عرفت كيف بس بتعدهم من الجدول. وهيدي يس وعكسها هي نو يس هيدي يس نو عكسها نو بس بتعدهم بتحطها.
I have a question.
Okay.
Here, you divided by 50,
So this is probability. Yeah.
but I mean this is probability that the ground is wet, not the ground is wet given that it rained.
No. Ground is rain given.
Ground wet given raining.
So
Yeah, but the 50
you shouldn't divide by
raining
50.
we should divide by 25 here
Yes.
because the raining day are 25. Because ground is wet given the weather is rainy.
This is the probability that
you're
the
right.
ground
You're
is
right.
wet.
So here we should where is the pen?
So okay, given
So here we need to
You're right.
divide by 25. Ground given not rain. How many not rainy days? Also 25.
Also 25.
25. I think also so, yeah. You're right.
5 over 20.
so 25 over 5. This
5
is
over 25, 1 over 5.
so can you just fix it? So just
So,
write
yeah.
everything is right. 11 over
So here it's correct.
Okay.
Here it's correct. So 15 over 25, it's 3 over 5. 3 over 5, yeah. 11 over 25, it's 11 over 25. 16 over 25 is also 16 over 25. And 1 over 5.
Okay. So okay, fine.
What is the last part? Give the maximum likelihood approximation for the 5 parameters giving these 50 observations. You just need to compute them, not derive the formula for computing them. Huh? Give the maximum likelihood
What?
approximations.
You just need to compute them, not derive the formula from computing them.
I think the formula for the maximum maximum likelihood.
So they ask to compute the exact value.
Give the maximum likelihood approximations.
You can go to the slide.
So let's go to the slide here. So minimize the low likelihood.
We need to
So
maximize.
maybe this was maximized, right? Professor said that.
C log theta L log 1
Yeah,
minus theta.
this is it's typo.
Oh.
This is maximize. So low likelihood, maximizing the low likelihood. So like this. And derivatives, calculate derivatives.
So I think it will be L equal. So C and L was the number of the days of rainy and not rainy. So it will be
So just using this formula.
25 log 2 P1 plus 25 log 2 1 minus P1 plus
Go ahead. 15.
15 log
P2.
to P2 plus 10 log 2 P2 plus 11 log 2 P3 plus 14 log 2 1 minus P3 16 log 2 P4 plus 9 log 2 1 minus P4 plus 5 log 2 P5 plus 20 log 2 1 minus P5.
So what we gonna do now?
So
What does this
25
estimate?
log half plus 25 log 1 minus, so also half, 15 log P2, which is 3 over 5, and so on.
And what does this estimate?
This is
What's the value of it? Like,
the maximum likelihood. This is the
So,
approximation
so
of
we
the
want to
maximum.
maximize this likelihood.
I mean, this is going to give us a value, right?
Yeah.
And what does this value,
This is
like maximum likelihood,
the
what does it do here?
maximum the log likelihood. Go down. Down. Maximizing.
So usually we assign the class from the observation. So to class Y, which maximize this likelihood. But here, I don't know. Here we have
Because here we use different classes, right?
rain or not rain.
So what are we maximizing?
So what is this? This is the same with this example. So after that they calculate derivatives del L over del every parameters and calculate zeta. So parameter zeta would be different after this calculation. So they assume this is already minimum, already maximum. So they just put 0 del L over del zeta, which means it's already the concave, the minimum point or maximum point for each variable, I mean the zeta, each parameters, right?
量化引擎，量化引擎，额外造成光点 n 零 q， 造成光点密度 n 零 q 可以通过采样来实现。
Yeah, use them. So let's see the.
Go to ChatGPT's solution.
So here, the maximum likely estimate of the parameters. The maximum likely estimation of the parameters of the statistical model. Observe data. The goal is to find the parameter that maximize the likelihood function. So we want to find the parameters. So these parameters to maximize this likelihood.
Go down. I don't know.
So the maximum likelihood estimate are just the empirical proportion in the observed data. This is a general property of maximum likelihood estimates for probability in a multinomial distribution.
我以后我推公式了。
Estimating the parameters. So the conclusion is like this. So we should read this one. So the conclusion is the maximum likelihood estimate often end up being the proportions observed in the data. That is the conclusion. And this is why we just count the event in each category and divide by the total. In our example, the parameter P1 is the probability of rain. To estimate this, we just look at the data and calculate the proportion of days it rained. The principle is generally true the probability in multinomial distribution, which is the underlying statistical distribution for naive-Bayes model with categorical variables. The multinomial distribution is a generalization of binomial, which describes the outcome of binary events. So when we say it's like just progression of the it means to find mathematics. And when we say this is the general property of maximum likelihood.
下一日有一些肉的，但是不是啊？
Okay.